Okay, yes, we do have an evaluation today. We're going to go over a couple things, 1, 2, 3, maybe a couple concepts that we hope will help you out, because on Monday we will hand out your second paper. Today you get your first one. Okay, you have a vocabulary evaluation today, and yes, we will get that here shortly. Probably the most important concept that we discussed yesterday, okay? Thank you. The most important concept we illustrated yesterday with your activity was what? Not just electrons, but more importantly, what type of electrons? Valence electrons. That's right. Okay? So, just to clarify it and make a short example of this, I believe one of your exercises was indolium, correct? Yes, I believe that is right. Okay? So when you went ahead and did this activity, you have your periodic table, and yes, you have your slide rule. And it's one of those aspects to where even when it's spelling, some of those anatomical terms that you saw up here, or when you're doing even dot diagrams or some of these Bohr models, Mr. Wagner, we've had this discussion before too, we can just glance at things and know whether, okay, that's right. And this is one of those characteristics too, because you can just glance at it and just say, that's got to be right. Because with the information that you know now, how many valence electrons does indolium have? It's 51. How many valence electrons would it have? Why is 3 correct?
It's in the seventh or physical.
Then it would have 5 valence electrons.
Oh, I don't remember.
You said 3, right? Remember, the column that it falls into will tell you how many valence electrons it has. It's in the third column. So we can illustrate that. Okay? So, in other words, again, this is starting to get to be old news. We're going to start to go a little faster with this, because I would expect that, one, if you're having problems, you're going to consult with someone or come talk to myself or Mr. Wagner or an upperclassman. Again, we want you to take that initiative if you feel you need extra help. So 1S2, yes? 49? Oh. Okay. No wonder you couldn't find it, right? Here's the periodic table right in front of me. Okay, 49. 1S2. 2S2, 2P6. 3S2, 3P6. Okay, something special happens after 3P6. What is that? Your slide rule tells you that. Yes, you have to go to the 4th energy level. And then that's 4S2. Then the slide rule tells you what? You got to go back to the 3rd energy level. 3D10. Okay. And then 4P6. Okay. And then what? 5P. It can hold 6. We're just going to put 1. Remember, you told me correctly that it has 3 valence electrons, right? That's got to be right, because here's 2 and there's that 3rd one. The column that it falls into will always tell you how many valence electrons it has. If it is neutral, but once it ionizes, then that number will change. We have not covered that yet. We've shown you that. But on worksheet 2, it's going to ask for you to do these when they actually have a negative charge or a positive charge. Okay? So when you look at indolium's box in the upper right-hand corner, it says +3. Well, what happens if these two disappear? Okay? How many protons are in the nucleus?
29.
Okay? So then, and we already know that this is right, we can just presume what happens when you add those two numbers together. You get plus 3, because those 3 electrons were given away. All right. So, what can you tell me the most important property for an element like potassium? Because what column is potassium in? It's element 19. It's in the first column. So why is that important? It's got 1 valence electron. All elements found in column 1 are called what type of, they're a specific type of metal. Alkali metals. Remember we talked about alkaline batteries? The reason they're called alkaline batteries is because lithium is used. Lithium is an alkali metal. Okay. So remember we skipped this middle group of 10 because those are transition metals because they have multiple charges. They're safe to handle, but yet we skip those because it is a rule of 8. All right, so moving forward. So now you're writing down what we have applied now for the last 2 weeks, maybe, okay? Because we did not start doing these Bohr models right away. Maybe towards the end of the first week. That might be a little more accurate. And it's when these cycles, or periods you could say, that's why they're periods on the table. They continually repeat themselves. And if we're making mistakes, let's try to make those corrections to help you out before you take your next big step in your academic career, which is, yes, I understand, it's still 4 years down the road because some of you probably have high goals for yourself when you move on to college, and we want you to be successful when you get there. Okay, I want to get through this next slide, and that's where we'll stop for today, and then we'll get you moving forward. Does everyone have this content that wants it? Okay, so last one we'll do for today. So last thing we'll mention is we just did element 49. So if we put element 13 up on the table, what would that, does that have anything in common with indolium? First of all, what is element 13? Aluminum.
Yes, three.
Why are you right, though? You're right, but why are you right? Because it's in the third column. And we cannot stress this enough. Elements within the same group or family have similar properties. They're not identical, but the property that they have in common is they've got 3 valence electrons because you correctly said it's in the third column. Okay? That's something that you're going to continually use that concept this year, and it will carry forward when you take general chemistry. Okay? So, do we feel comfortable with this? Back row. Okay? Front row. Okay? And then middle row. All right. So that's where we'll stop. We'll hand your paper out before the end of the hour, and we'll take your evaluation here shortly. Catch up to you next time.